Welcome back, students. In this app, we're going to explore the concept of slope. Okay, so let's see what controls we have. We can control the points. We can control the entire plane by moving it around. We can turn the grid on and off. We can turn the axis on and off. We can turn off the coordinate changes and turn them back on again in an animated fashion. We can keep it to one pair of points on one line, and we can turn on and off the status of the line. Let's bring this down to a bare minimum. Let's turn everything off. So now we're simply controlling 2 points as we do in geometry. Okay, there is no axis, no x-axis and no y-axis, and technically speaking this could be turned upside down. It wouldn't make any difference. Okay, in coordinate geometry what we do is we bring in 2 axes and they have their scales on them. So these imply a grid which we can turn on in a two-dimensional way, but it's still there even with the grid turned off once we have our axes and scales defined. Okay, now let's turn off the axis and turn on the grid, because at its heart this is all we need for slope. So let's begin with a really simple case that we're crossing one column, something like this. So what we want to point out here is that for a one step forward we're going a rise of 4, and the slope is defined as the rise divided by the run. Now something else to look at and to explore is the status. So we would call this an increasing line. Now you could say, but it's decreasing as you go from right to left. So instead of thinking this as a slope up a hill kind of thing, I want you to consider it to be maybe water level in a container as time goes forward. So this is why time is always graphed from left to right. So this is why this is increasing, because the level of the water is increasing this way. So this is increasing. If it's dropping, it's decreasing. So I don't want you to think about going against the curve and going from right to left. You just can't do that. You cannot turn back the time. Okay, so these are decreasing functions. These are decreasing values. This is a constant value of 4, and so on. But because for slope we don't need the axis, I'm leaving it off. All that matters is once I put the 2 points on top of each other now. So all that matters is once you separate 2 points, you get a slope. 1 point doesn't have a slope. There's loads of lines that go through them, but once you have 2 points, there's only one line goes through them. Okay. So here's another very simple slope where we go up 1 and we go out 4. I'm going to turn off the slope and ask you to start thinking about what the answer may be. How far do we go up? And let's show our changes. So we have a plus change of 4 and a plus change of 3. So the answer is 3 over 4. Now when the slope is decreasing, we call this, we instead of calling it a fall, we call it a negative rise. So a decreasing function has a negative slope. Okay, you see the axis doesn't really matter. Now when it comes to taking the coordinate values, which I can turn on, where is that? Okay, it only shows it if I have the axis on. Okay, and when you get this fraction, you should simplify it. Okay, and so one interesting happens. Let me just go. Let's go to the origin because it's simple. Let's turn off the axis and turn off those helpers for a second. So you see, say we go out 1 and up 2. Now if I'm to take this movement, if you like, this change, and repeat it, I'll end up here. And I get a slope of 1/2. So notice I haven't changed the slope. And the reason this is happening is essentially because we're able to break this up into fractions. I could go again. And I could make it more complicated, like a 2 and a 3. You see this rectangle here is being repeated in here. And it's repeated again here. So I have 6/9. So as well as just saying we'll reduce that fraction to 2/3, in a way what we're doing is we're sliding down along here to about here. Okay, and then once these have no common factor from your number strand, then that is the reduced simplified slope. Okay, now later on you'll be studying I must have another point belonging to this here. You'll be studying how lines can be parallel if they have the same slope, and then there's a way to have them perpendicular where they cross each other at right angles. So we'll come back to this then, but for now you can leave that second line off and just explore slope with this. Okay, as always, I'll see you in the next one.